I will be presenting on the paper The Wick and the Candle of Learning. Epistemic curiosity activates reward circuitry and enhances memory. So, curiosity can be described as a desire to learn what is unknown. It allows the mind to wander in multiple directions. And although some exploratory behaviors can be dangerous or can have harmful consequences, curiosity allows for great discoveries, inventions, and progress to happen. And we can all agree that it is an important trait of a genius, as seen with this example of Mona Lisa's painting here. Leonardo da Vinci, an artist driven by curiosity himself, has created a painting which led people to become curious over centuries over one woman's smile. And although there are some universal or shared themes that humans are curious about, there are also very peculiar interests. Here I have selected some from the field of scientists. These are some researchers that I found online, which have very interesting topics. But when does our curiosity increase and when does it decline? Well, according to the information gap theory, the theory suggests that when one receives a small taste on the subject of interest, which the individual does not know much about, their motivation and levels of curiosity increases until gathering the desired amount of knowledge, feeling that they know enough, after which curiosity reaches a plateau. Previous experts have compared this intense motivation one has to still their curiosity to our survival drive to eat when we feel hungry. Food has been regarded to stimulate the reward system in the brain. Hence, the information gap theory replaces hunger with curiosity and food with information to conclude that unknown information is rewarding. Based on this information, the authors of the current study hypothesized that the striatum must be linked to curiosity because evidence suggests that activation in human striatum is correlated with levels of reward. Which brings us to the overview of the study. So, the study selected participants from Caltech University who were presented with a series of trivia questions chosen to create a mixture of high and low epistemic curiosity. And participants had to read each question, then they had to guess the answer, after which they had to provide a numerical rating for the degree of interest in each of the subjects they read about. And after that, they had to rate their confidence levels in their answers before finally viewing the answer. All of the studies followed these steps. In study 1, the experimenters wanted to explore the brain areas activated during during curiosity, and they wanted to see whether the striatum will be activated when participants are curious about a certain question, due to feeling rewarded by the information they will receive. Study 2 looked whether this levels of curiosity would correlate with enhanced memory due to finding information rewarding and therefore learning better. And study 3 did a behavioral test to test the answers whether curiosity is indeed a form of reward anticipation. So on to experiment 1. The experiment selected 19 Caltech students who received $20 for their participation. And as mentioned, these participants read 40 trivia questions upon various topics, and they had to rate their curiosity ratings from a scale from 1 to 7, and their confidence ratings between 0 and 1. After completing the task, subjects had to provide their guesses of the answers outside of the scanner because it was hard to collect inside. The fMRI acquisition and analysis. The experimenters collected 3T Siemens. The scan sequences were 32 actual slices, and the data analysis was conducted using the random effects general linear model. Each subject trial was then split into two curiosity conditions, high or low, according to whether participants felt relative to their median curiosity level. So they created two curiosity conditions for each epoch meaning the steps mentioned before, which led to 10 regressors. The curiosity modulator analysis examined the activations and whether it increased linearly with curiosity levels rather than associated with two levels of high or low of curiosity. Moving on to the residual curiosity analysis, the authors investigated the P level, which represents the effect of curiosity that is dissociated from confidence level, and the level of uncertainty, which is P1 minus P. And they took the residuals from this regression to construct a new variable, the residual curiosity. They divided the answer display epochs into correct and incorrect guess conditions, which created further 6 conditions of interest as displayed. And now on to the results of experiment 1. Well, curiosity and confidence ratings. The information gap theory had suggested that curiosity should increase with statistical uncertainty. And this, in fact, was seen in this experiment. The reported curiosity was an inverted U-shaped function of P, reaching its maximum where P was around 0.50, and the curiosity correlated positively with uncertainty and with reward. Most subjects estimated peak curiosity was at P 0.45 and P 0.55. When we look at the brain areas associated with curiosity, the criteria for significance were an uncorrelated P below 0.001. There were significantly activated regions, which were the left caudates, the bilateral prefrontal cortex, and also the inferior frontal cortex. The activations were also seen in the hippocampus and Broca's area, which are areas related to memory and learning. These findings showed that curiosity not only activated brain areas involved in expectation and perception of reward, but, as mentioned, in memory and learning, which resulted in a new hypothesis and a new study. And in this second study, the authors hypothesized that participants would have enhanced semantic memory for the trivia questions they found interesting. After guessing incorrectly, participants would be more likely to answer a question if they were curious to know it. And they selected 16 Caltech students. The task questions and timelines were identical to those in experiment 1. There were minor changes, however. For example, the order of questions were fully randomized, and there were no fixation screens, and there was an inclusion of set duration for the display of each question and their answer. Upon completing the task, subjects were surprised with a request to return within 11 to 16 days for a follow-up study. So the measures included a follow-up session, which would determine their recall upon the subjects they were presented in session 1. And the results showed that when participants' curiosity expressed in the initial session had a strong effect on the subsequent recall of the answers to the question they had guessed wrong. The accuracy rates differed significantly between the curiosity levels. These results supported the hypothesis that higher curiosity levels led to better recollection. Participants displayed greater memory for questions they didn't know about due to the reward of the answers they received, which led them to store information better. Curiosity with the fMRI findings were consistent. This showed that these findings were consistent with the fMRI findings in experiment 1. This led to a third experiment, which looked, the final experiment was meant to confirm the findings on the relationship between curiosity and reward established in experiment 1. Specifically, what the authors here wanted to see was that activations in the striatum, initially attributed to expectations of reward, were not simply a result just of increased attention or anything but genuine interest in the subject area. In addition to variables mentioned previously, Experiment 3 also measured participants' eagerness to sacrifice their resource or time to acquire information. They did this by including 2 tasks and measures. There were 2 new additional conditions. Participants were either assigned to a token condition or to a time condition. The token condition looked in whether participants would spend 1 out of 25 tokens for questions they were curious about in order to receive the answer. And the time condition looked whether participants would spend up to 25 seconds waiting for the answer, thereby sacrificing their time to receive their reward, as in the answer. So researchers expected participants to prioritize reward, which are the answers, over the sacrifice, which were time or tokens, participants had to make. Moving on to the results. The results showed that participants were more likely to spend a token or time when they were curious about the answer, and they found a strong correlation between curiosity and the time, the sacrifice, due to expectations of reward. On to the discussion. The overall findings in the study suggested a significant relationship between curiosity and its link to reward, which was first seen in experiment 1 through the fMRI scans, showing activations in the caudate and midbrain regions. Since these activations were independent of participants' confidence, the authors suggested that participants perceived answers to be rewarding regardless of the accuracy of their initial guess. This suggested interest and motivation to learn more about the subject matter, which led to a second experiment. Activations detected in the hippocampus and Broca's area showed also that that participants would remember information better if they were curious and if they felt rewarded. Participants also showed dilated pupils before and after receiving the answers to questions of interest, which represented intrinsic motivation to learn more, even after receiving the answers. Finally, the last experiment confirmed the reward hypothesis and was in line with experiment 1. Participants spent more tokens than time for answers to their topics of interest, which was perceived as rewarding. Of course, there were certain limitations to this study. The authors did not explore all features of curiosity, wherefore future studies are encouraged to explore curiosity in response to nonverbal stimuli. If knowledge is power, then this study illustrated the importance of professions such as teachers or advertisers who inspire audience curiosity by distributing information. And we can all agree that curiosity did not kill the cat. Here is my discussion question, and thank you for listening.